students, welcome to Shruti Academy. So let us start with the Theorem 6.1 of Chapter 6 Triangles for Class 10 CBSE NCERT. So we will be proving the Theorem 6.1 in this session. Okay. So let us first understand what is the theorem. Okay. So the theorem states that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distant points, the other two sides are divided in the same ratio. Okay. So it means that if a line is drawn parallel to a side of a triangle, so a side of a triangle here is taken as BC and a line is drawn parallel to it, okay, such that it is intersecting the other two sides of the triangle. So it is intersecting the other two sides of the triangle at D and E points respectively. So for the side AB, the intersecting point is D, and for the side AC, the intersecting point is E. So it is saying that they are divided in the same ratio. That means AD upon DB is equal to AE upon EC. So basically we have to prove over here AD upon DB is equals to AE upon EC. This only satisfies the statement of the theorem 6.1. The theorem 6.1 is also known as the Basic Proportionality Theorem, or sometimes it is also known as Thales Theorem, because the Thales was the only one behind it. He kept on experimenting and he found out this theorem, and so it is also known as the Thales Theorems also. Okay. So we are given here that ABC is a triangle where DE is parallel to BC. DE is being made parallel to BC such that it is intersecting AB and AC at D and E points respectively. Okay, this is the scenario given to us, and we need to prove it that AD upon DB should be equal to AE upon EC. And a construction, we need to draw a construction, we need to join BE and CD, also draw DM perpendicular to AC and EN perpendicular to AB. In order to prove this theorem, this construction has to be made. So the first thing is that we should join BE. So I have joined over here, and we should join CD. So we have joined BE and CD. Second thing, DM should be perpendicular to AC. That means a perpendicular should be drawn on AC such that it should be DM and it should be perpendicular. Okay. So let us draw the perpendicular. So this is our DM and it is perpendicular to AC. This whole AC, it is perpendicular. Okay, then the second perpendicular should be EN, which is perpendicular to side AB. That means the rest of the two sides should have a perpendicular, should be drawn. That is mandatory. You can change the names, no problem, but the main thing is that the perpendicular should be drawn on the other two sides. So we will be drawing from here EN. Okay, so this is also perpendicular to AB. Now let us take the triangle. The first triangle, we will be applying the concepts of triangles which we have studied in class 9. So we already know the area of triangle, that is a right angle triangle, is given by half base into height. This thing we are going to apply over here. Okay, so the area of the triangle, first let us take the triangle ADE. Area of the triangle ADE will be equal to half base into height. So taking triangle ADE. So the area of the triangle is half base into height. So base is over here is AD, and the height will be naturally the perpendicular which is EN, which we have drawn on AB. So AD is also included in AB. AD is also included in AB. So the height of this triangle will be equal to EN. So let us write down area area of triangle ADE will be equal to half, base will be AD and height will be EN. Okay, so I am writing over here base, it is the base and it is the height. Okay. So let us mark it as equation number 1. Okay, so now let us move ahead towards the another set of triangle, which is a BED, okay, or BDE. So taking triangle BDE. Now taking triangle BDE. So similarly over here also the area will be equal to half base into height. Now BDE will be having the external height, which will be again how much? It will be EN, and the base will be DB. Base will be DB because my triangle is standing on this base itself, DB. So the base will be DB and the height will be EN. Okay. So area of triangle BDE will be equal to half, base will be DB and height will be again EN. EN over here is the external height. It is not included in the triangle, but it is the external height because the perpendicular is not included over here. So we are taking the external height of the triangle, which will be EN. Okay. So now taking the triangle to be ADE again, and this time we will be taking the base to be AE. Okay. So taking triangle ADE with base over here we will be taking AE. Okay. So let us mark this above equation as equation number 2. Now the area of the triangle ADE will be equal to half base into height. So base we are taking as AE and the height will be DM. In this case it will be DM. Base will be AE, and the height will be DM, this DM, okay, into DM. So I am writing over here, this is the height and this is the base. Similarly over here also DB was the base and EN was the height. Okay. So the another triangle which is left for the derivation is DEC. Okay, is triangle, taking triangle DEC. So when we are taking the triangle DEC, we are having the external height to be DM and we are having the base to be EC. So the area of triangle DEC will be equal to half, base will be equal to EC and the external height will be equal to DM, Okay, so let us divide 1 by 2 and 3 by 4. This is equation number 3 and this is equation number 4. So dividing 1 by 2 and equation 3 by 4. So when we will be dividing equation 1 by 2, we will be getting over here as triangle area of triangle ADE upon area of triangle BDE. BDE, BED or BD will be equal to half AD into EN upon half DB into EN. So this gets cancelled, this gets cancelled. So we are left over here with AD upon DB. AD upon DB. So let us mark it as equation number 5. Now dividing the equation 3 by 4. So equation 3 is area of triangle ADE upon area of triangle DEC. Triangle DEC. So it will be equal to half base is AE over here and the height is DM upon half. For the triangle DEC, the base is EC and the height is again DM. So this gets cancelled. DM gets cancelled, half gets cancelled. So ultimately here we are left with AE upon EC. AE upon EC. So this forms equation number 6. Now we can clearly see over here that the triangle DEB and triangle DEC, I'm just depicting in the figure so that you can figure it out. They both are on the same base DE. So whenever the triangles are having the same base and when they are between the same parallels, then their areas are always equal. We have already studied in class 9th. Okay. So the triangle DEB and the triangle DEC, they are between the same parallels DE and BC, and they are standing on the same base DE. So the area is equal. Okay. So the area of triangle DEC is equal to area of triangle DEB. Why they are equal? Because they are on the they are on same base DE and between same parallels. Okay, so this is the reason why these both the areas of the triangles are equal. Now we can clearly see that in the equation 5 and 6, area of triangle DEC is equal to area of triangle DEB or BED. Okay, you can write any of the thing. It is BED. Okay, so both the areas are equal. So we can clearly see in the equation 5 and 6 that the LHS of both the equations is equal. So when the LHS is equal, then we can clearly equate the RHS. So we come to the conclusion that area of triangle ADE upon area of triangle BED is equal to area of triangle ADE upon area of triangle DEC is equal to AD upon DB, and which is equal to AE upon EC. Okay. So ultimately we were to prove AD upon DB, which is equal to AE upon EC, and here we have proved that AD upon DB is equal to AE upon EC. So this is only our theorem. This is only our basic proportionality theorem. It says that if a line drawn parallel to any one side of a triangle such that it is intersecting the other two sides at some points and those points are D and E, then it is dividing it in the same ratio. So the AD upon DB, AD upon DB, AD this, DB is this, is equal to AE upon EC, and hence proved. Hence proved. Okay. So thank you. So please subscribe my channel, please share my videos, and if you have any doubt, you can ask me in the comment section. Thank you.